Hi, everyone. Thanks for joining to hear our zED talk on Db2 REST Services. Our presenter today is Tadas Varenekas, who is an IBM Z client technical specialist based in Chicago. He's been with IBM for over 3 years now with a focus on Db2 and Z analytics. He and his team have been hosting presentations and workshops on this topic for some time now. So he's well suited to provide assistance today and into the future for those customers who may want it. His presentation today will be about 30 to 40 minutes. If you have questions, please put them in the Q&A or the chat, and I'll be monitoring that throughout to make sure that we can address as many of those questions as possible before our time ends here today. Also be aware that the session will be recorded, and I'll send out a link of the recording once it's available. And there will also be a poll after you close out your WebEx window, so it would be great if you could take a minute to answer those questions to help us improve in the future. So with that, I'll pass it on to you, Tadas.
Thanks, Brian. I hope everyone can hear me okay. Like Brian said, my name is Tadas Varenekas. I'm a Z software technical specialist here. And we've been working on, I've been working with my team on this wildfire workshop for a while now, and we've had some great success with it. So I'm excited to share with you what we have to offer here, and we'll get started. One of the things that I want to address right off the bat is I will mainly just be talking to Db2 native REST service connection to Db2 subsystems. Before we begin, let's see here, just want to give you an idea of this agenda. I have modified this presentation today as it is a subset of a larger workshop that I host along with my teammates. Today, I will be covering this first section regarding mobile trends in the API economy, provide a RESTful API overview, and how Db2 for ZOS plays with REST services. In our complete workshop, we further discuss these REST services and how ZOS Connect Enterprise Edition interacts with them as well. And then we also provide labs to execute at your own pace for hands-on experience. So if you would be interested in this workshop or any other details regarding ZOS Connect and the Enterprise Edition, please feel free to reach out. My email is provided, and we can see if we can set something up in the future to bring this workshop to you. To begin, I would like to take a look at some mobile trends and how they relate to the API economy. In the recent years, mobile devices have emerged as a very powerful and insightful source of information. And with that, there have been different trends around mobile devices that have developed that can have significant implications for the enterprise. For example, mobile is primary. Almost everyone that I know, all of my friends, including myself, we keep our mobile devices and phones within arm's reach 100% of the time. If it's not my phone that's acting as my alarm clock that's on my bedside table, it's my watch that I'm wearing constantly 24/7 that's monitoring my sleep patterns, tracking my steps, my heart rate, etc. This being a fact of the matter that it is today, enterprises and companies can use these devices and the insights that they find from mobile data to provide new opportunities to their customers. Studies have shown that 75% of mobile shoppers take action after receiving a location-based message. This has the potential to turn a simple window shopper that's walking down Michigan Avenue. I know my mom loves doing that, being here in Chicago. Just walking down Michigan Avenue, window shopping, and all of a sudden she can get a notification on her phone from one of her favorite retailers because she just downloaded their application that is offering her 20% off of the next item she buys today in the store. Having access to that location and those location-based services, companies and enterprises can exploit that to offer new and deliver a contextually relevant experience for their customers. Mobile devices are also all about transacting, evidence of this being Cyber Monday. Back in the day, before Cyber Monday was a thing that people really responded to, they had to leave their houses on Black Friday at ungodly hours of the night just to get a good deal on their presents for that year. Nowadays, thanks to all these different mobile devices that we have at our reach, that are within our arm's reach 100% of the time, shopping at my favorite retailer becomes as easy as just clicking a button and having the product delivered to my doorstep 2 days later. It's a very valuable way that enterprises can drive revenue and productivity all through the simplicity of these mobile devices. One of these other trends that we've realized encompasses the continuous brand experience. I know for myself, when I'm using a specific service, or if I'm shopping online, or for example, streaming my favorite sitcom on one of the streaming services that are available, it's easier and it's so much more engaging to be able to pick up right where I left off on different devices. If I'm watching my favorite sitcom on my computer, for some reason I have to close it and I need to pick up my phone, I can continue to watch from that same exact minute that I stop and continue watching on my phone, or have the same experience shopping online on my computer that I do on my mobile device, on my phone. This widespread continuous experience across different devices helps deepen that engagement between the customer and the enterprise. The last mobile trend here that we have is that mobile devices enable the Internet of Things. A concept for me that it always blows my mind whenever I think about the Internet of Things, especially when it comes to the regular day-to-day home. I remember as a kid watching movies on how smart homes would be the homes of the future, and we really have, in a way, achieved that today. With the availability of the internet in everyone's home and all of these internet-connected devices, you can turn on your lights, you can lock your doors, you can do almost anything, change the temperature in your house, all from a simple mobile device on a simple, easy-to-use application. And the global machine-to-machine connections that are increasing dramatically every day and every year, the possibilities of what can be done and what kind of insights we can gain from a specific Internet of Things is almost limitless. So we know and we understand that these mobile trends are driving engagement, and they're becoming a very important part of the day-to-day life of a regular consumer. And these actions are able to deliver this data all through the use of APIs and the API economy. Next slide. Okay. What is the API economy? Now, if we're getting down to the details, it is the use of business APIs to positively affect that company. Business APIs are focused on providing a simple, easy-to-consume interface that is targeted toward the consumer of the API, who is most often the programmer. And the programmer can be anyone. It is the provider's choice as to if you're going to, who is going to consume your API, whether it be a public open API or a proprietary closed API that's only accessible within your company. Either way, the goal is to give the consumer an easy self-servicing mechanism. And on either side of this relationship, there are benefits. As a provider of the API, you can see an increase in revenue by charging the use of your API, and at the same time, you can extend your customer reach by opening your API to the entire API economy, and therefore allowing people to use your API, extend your customer reach, therefore also increasing your revenue as well through those mobile and web applications. As a consumer of the API, using the other open APIs that are available in the API economy, this allows developers to stimulate innovation in their applications based off of, if you're using an API that provides a service for one portion of your application, you don't have to worry about maintaining that code or that feature of your application. You can then think and develop new ways and new features for your application, giving you more time to do so. And at the same time, it also cuts down on your time as a developer. By using different APIs and different sources for features of your application, it can increase the speed to market and develop and give your application out into production faster. So APIs are not just a fad. They have been growing significantly over the past few years. And there are several different focus areas that APIs have been touching, such as digital transformation, blockchain, IoT, cloud computing, and etc. These business APIs have become the kind of de facto interface for these new initiatives that are moving forward as use case examples where APIs provide the consumption and security context around the assets being exposed. As you can see, just based off of this simple chart here, APIs are way past the fad stage. They are being implemented in real projects. Industry ecosystems are being formed based off of them, and in some cases, regulatory requirements and industry standards are being developed around these business APIs. They're a really important tool, and they're a great way to exploit the mobile trends that we discussed earlier as well. I wanted to bring in a couple of examples here that illustrate how public APIs have affected different companies over the past couple of years. Each of these numbers for Expedia, eBay, and Salesforce respectively, these are the percentage of revenue that they have made from public APIs. This information is from 2015. So as you can imagine, over the past couple of years, along with the growth of APIs, many more companies have also seen a growth in their revenue based off of public APIs significantly. Before moving on to RESTful APIs, I wanted to take a brief pause here and see if there were any questions in the Q&A or in the chat. Feel free to throw those in there. As Brian said, I'll be taking a couple more pauses to check in on you guys as well, to see if there's anything that you want some more explanation on. Looks clear right now. So moving on, I'd like to give a brief technological overview of RESTful APIs. Now, to understand what a RESTful API is, first we need to look at what REST is. And REST is an architecture. It stands for Representational State Transfer. The properties of the REST architecture are that it's stateless, it's based on a client-server relationship, meaning that the client sends out a request to the server processes that request, and then sends back a response. It is also based on a cacheable communications protocol. Most often why HTTP is used due to the relatively easy way that both of those, the protocol and the architecture, work hand in hand. And then a RESTful API is an application programming interface, and it uses the HTTP request to get, put, post, and delete the data. So kind of big picture, the best way that I can sum it up is that REST is the architecture, and for a RESTful API, that refers to the web services that implement and use this architecture. One thing that I want to point out that I'll go into a little bit more later on is that DB2 native REST only supports the post method for applications. GET can be used for some system-related functions, but not applications. So therefore, in the zCEE, the API editor, that allows you to reassign the post to a different method, which is what we also explore further in our other presentation. So this is one of the reasons why DB2 native REST just uses the REST architecture, and zED is a RESTful application that uses the HTTP verbs. So I wanted to go through a couple of the key principles of REST. Now, this architecture pairs the HTTP methods with the URI, which is also known as the Uniform Resource Identifier. The pairing of the method with the URI allows the architecture to accomplish what the service is trying to do. So if we look at the URI here at the top and break it down into each of its portions, we see that the URI includes the destination as to where this request will be sent, which is the host and the port number, the path that it's accessing along with the parameters and the name value pairs of the information that you're trying to access. So for a simple request, as an example underneath on the bottom here, we see that there's a get method being paired with the URI that is accessing the acme.com host, going to the customer path, accessing the customer 12345, requesting that the personal details be sent back. The request is sent out, just the URI along with the method, and then the server responds with the response with a 200 HTTP response code indicating that it was successful, and the body of that response returns all of the personal details for customer 12345 in JSON format. Another example that I want to abstract a little bit here in regards to DB2, we see here this example of the URI at the top that goes to my host, customer 235. So the pairings of the URI along with each of the verbs, each of the HTTP verbs, get, put, post, and delete, all execute a different function. So taking the URI at the top for customer 235, pairing this URI with the method get, returns the record for customer 235, which in SQL terms is a select. Taking the URI, pairing it with the put method, along with extra information in the body of the request in JSON format, will update the customer 235. Pairing the URI with the post, along with more information in the body, creates a new record for customer 235 in SQL terms and insert, and then pairing the URI with the delete method will then simply delete customer 235. Now, the difference DB2 native REST executes in regards to these methods is that, as I mentioned before, only the post method can be used for applications, which can be counterintuitive because, for example, if you're trying to delete a customer, you would still have to pair this URI for customer 235 with the post method, and then in the body of that request, detail what you want to do with that customer. For example, in the case of it being deleted, you would take the URI, pair it with the post method, and then in the body of the request, enter your information in order to delete that customer and then send it off to the server. Like I said, it can be a little counterintuitive, and this is one of the reasons why DB2 native REST is REST and not RESTful. When it comes to this, in regards to zED, you can use the API editor to map the post method to its intuitive verb in order to accomplish what you're trying to accomplish. So you can take that request, map it to the delete method, and then through that API, it will be an intuitive pairing of the URI with the delete method in order to delete your entry. There are often a lot of questions regarding this, and I hope I did a good job explaining it. I will take a little quick look if there are any questions. Looks like we're good. So why is REST so popular? Well, it is increasingly common over the past couple of years. The pairings of REST and JSON has become more and more kind of the de facto standard for exposing APIs and microservices. It's relatively lightweight compared to other technologies such as SOAP and WSDL. The REST and JSON maps very well to the resource-limited devices. Has a ubiquitous foundation that is based on HTTP, which operates on the TCP/IP networking technology. It is relatively easy regarding development. Developing the client only involves a few understandings of the URI requirements and JSON. And it is also stateless, which allows greater simplicity in the topology design, excuse me. Having covered the RESTful API section, I'd also like to take a little brief pause here. Check on the Q&A. Looks good. So we will move on to see how these REST services relate to DB2 and DB2 for ZOS. So the objectives for DB2 for ZOS are as follows. We want to be able to use REST and JSON to invoke one SQL statement or stored procedure. And within that SQL statement or stored procedure, you can do a multitude of different things. The second is we want to enable business value for your enterprise data, trying to get at those mobile trends that we talked about at the beginning as well. The third is then modernizing and using the power of SQL. And lastly, unleash the DB2 data for the API economy, again, going back to those mobile trends and allowing your DB2 data to play a part in those mobile applications, being able to use DB2 data in the API economy effectively and leveraging that to your business's benefit. A couple of things I wanted to address regarding the specifics and the requirements regarding DB2 REST services. The DB2 REST service invocation is through DDF access, which is standard, which is how we have accessed DB2 data before, but there is a slightly new access, but it still goes through DDF. I have an architecture diagram coming up in the next slides to illustrate this further. Some of the service details, as I mentioned in the objectives, only one SQL statement or stored procedure call is permitted per service. And the service is a statically bound package in DB2. The REST services also support call, delete, insert, select, truncate, update, and with. And the only thing that I want to point out here is that the merge can be used in a stored procedure, but not a service. And lastly, all of the various DB2 SQL data types are supported, including blob, cloud, DB cloud, and XML. So here's the architecture diagram that I briefly mentioned before. Traditionally, when we're accessing DB2 data for an application, this is kind of the abstracted overall view of the architecture. So for DDF access before REST, we normally use a JDBC driver, ODBC, or .NET, what have you. When to access DB2 through a specific port number into DDF, which then performed the DRDA parsing and further went down to get the DB2 data via authorization check, thread creation, and SQL execution, brought the data back and sent it back to the application. When it comes to native REST access for DB2 data via a mobile application using JSON data, here you can see that the application is still accessing DB2 through the same exact port number and going into DDF. However, there is a new HTTPS and JSON parser that is inserted here that is able to parse the information and get to the DB2 data the same exact way from that point on as DRDA parsing went, or the process that DRDA parsing went through. Authorization check, that thread creation, SQL execution, get the DB2 data, send it back to the mobile application. So from the application standpoint, it all pretty much looks the same. You go through that port number to access DDF, and the rest is automatic, simple, and easy, just the way that the same exact way that it has been done before. So regarding the DB2 REST service management and creation, execution, there are two different personas that we're talking about here. Sort of an application developer that is working on the mobile application, and the DBA that is taking care of the DB2 data. From an application developer's perspective, they're the ones that are going to invoke the DB2 REST service, or look at the output return that's in JSON format, and move on with their development of the application. They're able to invoke the DB2 REST service that is consisting of potentially a stored procedure or a SQL statement, but that doesn't matter to them. They don't need to know that. And they also don't even know that the data came from DB2. They just executed it and received it back, and they're happy with what they can continue on working for their mobile application. The DBA is going to be the one who creates the service that the app developer uses that will consist of an existing stored procedure that you may have or a SQL statement that they created. They, as I said, they can reuse the stored procedure in a REST call, and they don't really need to know JSON at all. That is what the app developer is going to be seeing. The DBA doesn't need to worry about that. There are a few different ways in managing these DB2 REST services that the DBA is going to be managing. There are a couple different interfaces. There is a REST client that you can install in your browser. Most browsers support this, whether it be Chrome, Firefox. All you have to do is download a plugin, and it will allow you to create and manage those services. There are REST applications that have a kind of a browser look and feel. Some may have heard of the client Postman that has a lot of functionalities regarding the service creation and management, and it has become very popular over the past couple of years as well. Or you can manage the DB2 REST services via bind subcommand, which is just the standard DB2 interaction. So I wanted to bring to life a little bit this DB2 REST service progression. First, the way that a DB2 REST service is going to be created is by discovering what services are already existing on the DB2 subsystem. A couple of privileges and authorities that you need to be able to discover the REST services are listed here. And anyone can really discover these services as long as they have the right connection information. When we're speaking to the personas that I had in the previous slide, an app developer or a DBA will be the ones to we'll both have should have the opportunity to discover a service. The procedure for discovering a service, again, as long as you have this correct information, goes as follows. It's going to be a post method along with the URI, and your host port information is the location of, or is your DB2 subsystem. The path is going to be service, and the DB2 service discover is going to be the service that is going to be executed to discover these services. To discover all the services that are available on the subsystem will just be in the path denoted as services. You can see those services by pairing that with the get method. Upon successful completion of this service, you will receive a HTTP status code of 200, a 200 level, meaning that it is successful. Any other status codes that you may get, standard HTTP codes, are the levels of 100, 200, 300, 400, and 500. These are HTTP codes, not DB2 codes. This has to do with the communication between the client and the server, the relationship. So it'll detail some, it'll give you some more detail as well as to what happened, whether it be a server error or a client error. Those are the main two different errors that can be experienced when issuing these services. So moving on from discovering a service, the DBA is going to be the one that is creating these different services. A couple things before you would begin would be to, when you create a service, DB2 identifies you or the authorization ID that you use as the default owner of the service. This has to do with versioning as well later down the line. If you want to create a new version of the service or update it in any way, it's the owner of the service that can do this. So you must have required privileges to create the service and bind the associated package into the collection. Here's as an example, you must be authorized to execute the SQL statement that is embedded in the service. The procedure for creating a service is similar as to discovering. Notice again that we're using a post method to the DB2 Service Manager because DB2 native REST is only executes the REST architecture and is not RESTful. So the format, you can view details, the details of the JSON in the Knowledge Center as well, but the format of the body of the request must be in JSON in order for the HTTP parser to correctly parse and understand the information. Each of these fields are required in order to successfully create the service. Again, we're looking for a successful completion status code of 200 to understand and make sure that the service is created. Once the service is created, you can go back and discover the services that are on your DB2 subsystem to make sure that your new service is there and successfully created. It should then, unless you receive some sort of error code, it will not, it should be presented in that view in the response from the server. The following, the last three of the following aspects of interacting with these services are displaying the service, executing, and then deleting the service as well, each of which the procedures are very similar, if not identical, to the create the service, just with different parameters depending on what you want to do. Displaying the service is going to be done mainly by an application developer to understand what a service is doing. It basically just displays the schema of the service so that they can understand what parameters are required, how they need to access it, and what the service actually does. They will also mainly be the ones that are executing the service in order to get that data back and be able to use it within their application. And then deleting the service based on authorization and authentication IDs, that will be something that the DBA has control over, same as creating the service. You don't want to give your web developers a authorization to be able to manipulate and manage those services themselves. That should be a request that is put in to the DBA to be able to manage the DB2 data or show and allow the web developers to interact with DB2 data the way that they want to. All this information is available in the Knowledge Center as well. You can follow that link and learn more details about each of those procedures as well. So that brings my presentation to a close. I really appreciate the time and everyone took to participate today. And if there are any questions, please do not hesitate to reach out to me. And if you're interested in a potential workshop and to learn more about how z/OS Connect Enterprise Edition plays in this space, we will be more than happy to set something up and allow you to get some hands-on experience with these services. With that, I thank you very much. And if there are any other final questions, I would be glad to take them now.
Yeah, great job, Tadas. Thanks again for presenting today. We did actually have one question come in. I think it related to a few slides back. The question is there a way to identify these REST services to the z/OS Workload Manager as service classes?
Excellent question. If I'm understanding correctly, I don't think for some reason I can't see it in my Q&A here. But so the question revolves around identifying these services via Workload Manager. And the answer is yes. The identifying these services for Workload Manager is based off of the classes. And this also is very valuable when it comes to pricing, because the more that a service is going to be, the more that a service is going to be executed, the more that your CPU usage is going to increase as well. So identifying the classes for these services is something that the Workload Manager can do. And if I remember correctly, we will be able to reduce your pricing based off of your CPU consumption up to 40%, I believe. I don't have that information ingrained in memory, but it is possible, yes.
Okay, great. And we have another question here. This one relates to z/OS Connect as well. Is it a good practice to have z/OS Connect to generate RACF pass tickets for authorization to invoke DB2 REST services?
Invoking RACF, what was that again?
Here, I'm going to make sure you have the question as well. But it's, is it a good practice to have z/OS Connect to generate RACF pass tickets for authorization to invoke DB2 REST services?
I would, based off of the question, I don't really have much experience regarding the security. That is one thing that we want to expand upon with our workshop and create more detailed information regarding RACF and the security for around DB2 REST services. Based off of the question, I would assume yes, it would be a good practice, just so long as the right authorization and authorization IDs are able to access the DB2 REST services. I would love to jot that question down and do some more research and get back to whoever asked that question.
Okay, sounds good. We can do that. Okay, that looks like all the questions for now. So thanks again for taking the time to present today. To anybody out there, if you have more questions, please reach out to either Tadas or myself. And again, you know, Tadas hosts this great workshop related to this topic, as well as z/OS Connect. If you guys want more information about that, feel free to reach out as well. As a reminder, I'll send out the recording of today's session along with the presentation deck. So if you want to access some of the links that were available within there, you will be able to do that. And finally, when you close out your WebEx, please fill out that survey. That'd be really helpful for us moving forward. So thanks again for tuning in, and we're looking forward to our next zED talk next month, which will be on Ansible on Z. So thanks again, and have a good rest of your day.